These cell site antennas and mobile antennas are deal with the antennas which are installed in the cell site, that is at the base station, and also the antennas which are at the mobile unit, that is nothing but our mobile phones, and different parameters related to both these antennas and what are the radiation patterns, what are the types of antennas. All these parameters have to be discussed in this unit. And also about antennas, we already learned on AWP, the basic concepts related antennas, right? But if you observe the surface framing in CMC, starting unit, that is in first unit, we gave about the cellular mobile radar system, right? That means in first unit, he's dealing with what are the basic concepts in cellular mobile communication, also what are the cellular radar systems, cellular mobile radar systems. That is, what are the components involved in cellular systems, what are the early mobiles, and what are the differences between different generations, and the evaluation of cellular communication, right? And what are the advantages in analog systems and as well as digital, and also the disadvantages in both the systems. That means the basic introduction related to cellular mobile communication is introduced in this, and also the cellular concepts. What are the important concepts related to cellular technology? That is about the frequency reviews concept, and also the cell splitting, cell sectoring, and what are the cells and why the trunking and blocking, and also the GOS related to what are the size of cells. All these basic concepts related to cellular mobile technology are introduced in this topic. Coming to the next one, that is second unit, that is about interference. Interference is nothing but the adding or modifying and also the altering the original signal, that also the regular communication signal, right? And also it's, we are call it as an unwanted signal. We are call it as an unwanted signal. Interference, right? An unwanted signal. Basically, this may be caused with different channels in within the cell, and also the outside the cell. And what about the different interferences, and also about the receivers and transmitters are discussed in the second interference. Right. Coming to the frequency management and channel assignments. This is the recent unit, the frequency management and channel assignment. In this, the frequency management, the numbering and numbering the channels, and also grouping the channels. Whereas the channel assignments, the sharing of the channels, and also the fixed channels, non-fixed channels, fixed assignments, non-fixed channel assignments. All these are comes under the channel assignment, right? The second part of the third unit comes under cell coverage, And the other one is cell coverage for signals and traffic. That is nothing but the signal coverage and also the traffic coverage. That means the signals are ideally covers the entire cell, that is 100%. Now, what are the different techniques? That means human-made structures and also the natural structures. How the signals propagates through these structures, and all these are comes into picture in this unit and this chapter. These are about the starting 3 units of syllabus, right? And the other one is the now that is about cell sites and mobile antennas, right? Both the antenna, this topic broadly under the deals with the antennas like directional antennas and also omnidirectional antennas, also the cell structures and high gain antennas, right? There are limited topics, but some derivations are there. This may be related and you studied, you may studied in the AWP, right? Now coming to the basic introduction about antennas, we are aware of that antenna is the transceiver. Antenna is also called it as a transceiver. That means we have to transmit and receive the signal, right? Here, an antenna is here. An antenna is a device which is used to transform an RF signal, right? Antennas are radio frequency signal traveling in a conductor through conductor into an electromagnetic wave in free space, right? That means the antenna transforms the RF signal through an electromagnetic wave and received by another antenna or maybe a receiver like that. Here the antennas, the first antenna was built in 1888 by H. As we are the unit of frequency nothing but H. That means his name is named as a unit for frequency, right? Which generally an antenna it consists of an arrangement of elements. That means arrangement of the conductors. Elements are nothing but the conductor. The type of arrangement will be different for different antennas. but these elements are connected electrically. Generally through a line, a transmission or transmission line is nothing but a wire. This may be a receiver or may be a transmitter, right? Maybe a transmitter or a receiver, right? The antenna consists of an arrangement of conductors which are electrically connected, right? To the receiver or transmitter. And the other one is the antennas are reciprocal. That means here the antenna, suppose take an antenna at the transmitter, exactly the reciprocal for receiving system. So, that means the transmitting system and receiving system both are reciprocal at the antenna. The antennas are reciprocal, right? The one is the radiation mechanism. The how the antenna radiates energy, right? Generally, in ideal cases, the radiation mechanism, the all incident energy must be reflected back when open circuit. That means the transmitted signal will be reflected back in an open circuit. Generally, but a small, not all incident energy must be reflected back, but some of the a small portion of the energy will not be reflected back, right? And also the small portion of energy escapes from the system, right? The escape energy is small due to mismatch between transmission lines and the surrounding space. That means there is no impedance matching. For this, there is a mismatch between transmission lines and the surrounding space. And also, the two wires are too close to each other. That means two wires are close to each other. The radiation from one wire will cancel the radiation from the other wire. Like the circuit diagram shown here, if they are opposite direction, the distance between them is very small compared to the wavelength. in the radiation mechanism, if we increase the radiated power, the open circuit wires must be spread with a distance. Must be spreading with a distance. Because of this arrangement, between when the distance between the two wires are very high, coupling between the transmission lines and the free space is improved. The free space and the transmission lines will be improved. Due to this, the cancellation, the amount of cancellation is reduced because of spreading of the two wires, and also the radiation efficiency is also increased. And the other one is the types of antennas. There are the basic types of antennas. Generally, antennas are classified into two categories: omnidirectional antennas or directional or beam antennas. Generally, the omnidirectional or weakly directional both are same. The weakly directional means the antenna radiates in all directions. Receiver radiates more, but the antennas propagate to all directions, but there are weak strength is less. These omnidirectional antennas are used when the position of other stations is not known. And the position of the other stations is not exactly known there. And also these omnidirectional antennas are used where the low frequencies are used. Where the low frequencies are used, there we are using the omnidirectional antennas. Also, there are too large here, where the directional antenna would be too large. That means the cost of directional antennas are high compared to omnidirectional antennas. To reduce the cost, directional antennas are not used where the low frequencies are. So the directional antennas are very high requirement. For the case of omnidirectional antennas are used. Others coming to directional or beam antennas. These antennas are intended. That means these are mainly used. These are mainly used to transmit or receive. These are mainly used to transmit or receive in a particular direction or directional pattern. the directional or the directional pattern. That means where the signal has to transmit or receive in a particular direction, then we are using the directional antennas. Whereas we are not sure about the direction, where we are using the omnidirectional antennas. The omnidirectional antennas. Here is a circuit diagram for both the directional and omnidirectional antennas. Where here the directional antennas, which is the power or the signal transmitted through only one direction. Whereas in omnidirectional antennas, the signal transmits and radiates in all the directions, right? And also there are other two types of antennas are there. This category is based on according to the length of the transmission line. Whereas here the categorized antennas based on the direction of radiation. Direction of radiation. Here the length of the transmission line. Here the resonant antennas. The resonant antenna is a transmission line. It is a transmission line. The length of this transmission line is exactly equal to the multiples of half level length. Multiples of half level length. And it is open. And it is open at both ends. It is on both directions. These are multiples of half wavelength. That means in resonant antennas, the length of transmission lines is exactly equal to multiples of half wavelength. That means lambda by 2 in terms of lambda by 2. Whereas in non-resonant antennas, the length of the antennas is not equal exactly to multiples of half. That means there is no need of the length of the antennas is multiples of the half wavelength, right? In non-resonant antennas, the standing waves are not present as antennas are terminated in correct impedance. With the avoid reflections, these antenna waves are in a correct impedance. And also the waves travel only in the forward direction. In non-resonant antennas, the waves are travel in only in forward direction, not in backward direction. And also the non-resonant antennas. The non-resonant antennas are directional antennas. Unidirectional antenna, the unidirectional is nothing but the power radiates only in one direction, right? There are also other category of antennas are here. Coming to the principles of antennas, we will be discussed in another class. For now, the introduction to antennas. And also the topics are regarding the cell-set antennas and also the types in unidirectional antennas and omnidirectional antennas. Right? Here the antenna principle are there. One is the radiation resistance. Radiation resistance is nothing but the radiation power by I square. Means power supplied to the antenna and also the current flowing into the antenna. Radiation resistance is nothing but with regards to where the power is nothing but the radius the power is supplied to the antenna. How much power to supply to the antenna and also the current flowing into the antenna. Another one is if the radiation resistance R is high, then the more energy is radiated or received by the antenna. The more energy is radiated or received by the antenna, where the resistance is high, that means if the resistance is high and also the power is directly proportional to the resistance based on this above formula. In this, the energy radiation is more and also the received by the antenna. For the better antenna system, for optimal antenna system, this resistance for better antenna system, this resistance should match the resistance of the transmitter or receiver system. That means the radiation resistance should match with the resistance of the transmitter or receiver. Radiation resistance has to match with the transmitter or the receiver. Here the antenna pattern shows that the distribution of the radiation power. This power antenna pattern shows distribution of radiative power. As a function of direction in space. It shows a direction of distribution of radiative power as a function of direction in space. Like the power distribution of the radiated power will be displayed by using a polar plot. We are already aware of this. Based on this, in which direction the antenna radiates, the more power will be determined by using the polar plot, right? And also this example shows an antenna that radiates a lot of power in one direction but very little in other. If you observe this polar plot, this looks like a directional antenna. This looks like a directional antenna. That means the antenna radiates more power in one direction, very small power in the remaining direction, right? Here the angular power will also be detected by using these polar flats. Coming to the basic points related to the antennas are unlike the antennas, the basic principle of antennas to transmit or receive a signal by using the antenna is arranged of the conductors, metallic conductors to a wire. It will be arrangement of the conductors by using a wire. These antennas are used to transmit and receive the signals. These antennas are categorized based on the principles. Two types. One is the omnidirectional and other is the directional antennas. In omnidirectional, these types of antennas are used to radiate the power in all directions, but these signals are not strong. These omnidirectional antennas are used where the receiver is unknown, and also the low power is required, and also the very small distances. So in those cases, we are using the omnidirectional antennas. But if we use the directional antennas there, the maybe cost is high for that. To reduce the cost, we are using omnidirectional instead of directional antennas. Coming to directional antennas are radiates the power in only one direction. Radiates the power in one direction. So, and also by considering the length of the transmission lines, we categorize these antennas as resonant antennas or non-resonant antennas. If the antenna length is multiples of half of the wavelength, that means lambda by 2 multiples, then it is called the resonant antenna. Otherwise, it is called as non-resonant antennas. Right? These are called the non-resonant antennas. These non-resonant antennas are used to also these signals travels only in forward direction. These non-resonant antennas are also called as direction antennas. These are also called as the direction antennas. Right? This is about the basic about the antennas.